Hello everyone, you're welcome to this class, and I quickly want to take you through the qualitative analysis section that you are going to be doing on Monday. So C and D are the sample that you will be given, and you know that C is lead triazonitrate 5, while D is potassium triazosulfate 4, that's K2SO4. So, and the reason why I did not write question like that is because for NECO practical, under the test side, they will fill everything already for you. They will fill everything. So you are the one that will fill the observation and the inference by yourself. It's unlike WAEC. In WAEC, you have to draw the table by yourself. But in NECO, they will draw the table for you. You just fill the observation and the inference side. I hope you understand that one. So that means you have to understand some of these concepts, so you don't need to cram like that. Let's look at number 1. Put all of C into a beaker and add about 10 cm cube of distilled water and shake. So sample C dissolve in water to form a colorless solution. And the reason why sample C will dissolve in water is because all triazonitrate 5 are soluble in water. All triazonitrate 5 are soluble in water. It has NO3 there. Any compound that you see that has NO3, it is soluble. So sample C is a soluble salt. And when you add litmus to it, you will notice that it turns blue litmus paper red. So instead of writing sample C is acidic, you have to write solution C is acidic. And in that observation, don't just write C is soluble. You must write sample C or just C dissolve in water to form a colorless solution. I hope you understand that one. Now let's look at that number 2. First portion of solution C, then sodium hydroxide solution in drop and in excess. So while a white precipitate is formed in drop, it actually shows whether lead 2 ion is present or calcium ion is present. But when you now add it in excess, the precipitate dissolves to form colorless solution. It actually signifies the presence of lead ion. Assuming that it's calcium, and calcium will not dissolve it in excess, but lead will dissolve it in excess. So number 3, the second portion of aqueous ammonia in drop and in excess. So the white precipitate is formed in drop, and then the precipitate is insoluble in excess. It actually signifies the presence of lead ion too. Now, that fourth portion is what we call confirmatory test. And there are some other way that I'm saying it, but I still think that you might bring something like this. So third portion of solution C plus drop of potassium tetrahydrochromate 6 solution, that's K2Cr2O4. So a yellow precipitate will be formed, and that is a confirmatory test for lead 2 ion. It's a confirmatory test. So you won't write present anymore, you will write lead is confirmed. So that's a confirmatory test. Now number 5, that's for the sample D. So when you eat it, a lilac color flame is observed, and that shows the presence of potassium ion. Then number 6, sample D plus distilled water. So sample D dissolve completely in water to form a colorless solution. And the reason why sample D is soluble in water is because of the presence of the potassium ion. You know that all sodium ion, potassium ion, and ammonium ion are soluble in water. So sample, you write this completely dissolved in water to form a colorless solution. And sample D is a soluble salt. It's also an alkaline. Then number 7, look at number 7 and number 8. And that number 7 and number 8, it is just optional. They might ask you to pick, do one or the other one. So depending on what they ask you to do, that's why I put all there. Also solution D plus BaCl2 plus dilute ACl plus warm. So you will see a white precipitate form, and these are the compound present there. So the white precipitate dissolve, and a colorless gas with irritating smell is evolved, and the gas decolorizes KMNO solution. So it shows that SO2 gas from SO32 minus is present. Or solution D plus BaCl2 aqueous plus dilute ACl plus drop of acidified KMNO4. That means it's possible for them to ask you to add a little H2SO4 to that KMNO4. So a white precipitate will be formed, and is present is already on the screen. So when you now add drops of acidified KMNO4 and dilute ACl, the white precipitate dissolve and the mixture decolorizes KMNO4 solution. So SO32 minus is present as a reducing agent. So thank you very much for listening. So please don't forget to like and subscribe. You will be helping my channel. And I still have a PDF file, but maybe I'll drop it later in the evening. So let us first look at this and study properly first. Thank you very much, and bye bye.